Good morning, students. Now we discuss about fractional distillation of crude oil. Here, the crude oil is derived from earth crust. That crude oil subjected to fractional distillation process to get various useful fractions like petrol, diesel, kerosene, solvents, lubricating oils, etc. Now, in fractional distillation process, the crude oil is heated to about 400 degrees centigrade in iron retort. Now, here the crude oil is passed through iron retort. It is about 400 degree centigrade. Now, at this temperature, the crude oil becomes vaporized. Hot vapors. Here, these hot vapors consists of various fractions like petrol vapors, kerosene vapors, diesel vapors, and solvents like naphtha vapors and other heavy oil vapors. Now, these hot vapors passed up a fractionating column. Here, fractionating column is a long cylindrical tower. Here it is the fractionating column. Fractionating column is a long cylindrical tower. This tower consists of number of steel trays. It is the steel tray. Each tray consists of small chimney with loose cap. Number of trays with chimney with loose cap. Okay. Here, as the vapors go up, in the column, here fractional condensation takes place at different heights of the column, and different fractions are separated on the basis of their boiling point. Here the different fractions separated are: the top fraction is uncondensed gas. It is the uncondensed gas. And the other fractions separated are: now it is ether, called petroleum ether. Next fraction separated is petroleum, petrol or gasoline. Next one is naphtha. Next one, kerosene. Next, diesel. Next, heavy oil. Here, these are the different fractions separated from the crude oil on the basis of their boiling points. Here, the lower fractions are called heavier fractions. Heavier hydrocarbon fractions. The top fractions are called lighter fractions. These are lighter fractions are lighter hydrocarbon fractions. Top fractions are called lighter hydrocarbon fractions. Lower fractions are called heavier hydrocarbon fractions. Here, the heavier hydrocarbon fractions are separated out first and then lighter hydrocarbons are separated. Here, the heavier hydrocarbon fractions possess high boiling points and lighter hydrocarbon fractions possess smaller boiling points. Now, mention the boiling point ranges for these fractions. Now, for uncondensed gas, the boiling point range here it is less than 30 degrees centigrade. Less than 30 degrees centigrade for gases. For the fraction ether, the boiling point range is 30 to 70 degree centigrade. For petrol or gasoline or motor spirit, the boiling point range is 40 to 120 degree centigrade. 40 to 120 degree centigrade. For naphtha, the boiling point range is 120 to 180 degree centigrade. For kerosene, 180 to 250. For diesel, 250 to 320. For heavy oil, it is 320 to 400 degree centigrade. It is about 320 to 400 degree centigrade. Here, see the different fractions goes up in the tower. Here, the fraction, for example, petrol. Here, the petrol boiling range is 40 to 120. 40 degrees centigrade to 120 degrees centigrade. That means the petrol is in vapor state above 40 degrees centigrade. Yet and above 40 degrees centigrade, the petrol is in vapor state. When the temperature below the 40 degrees centigrade, that vapor becomes condensed and converted into liquid and that is separated out. Here, see the first fraction is heavy oil. First heavy oil is separated from the crude oil. Here the heavy oil boiling point is 320 to 400 degrees centigrade. Here in the tower, the temperatures maintained from 400 degrees centigrade to room temperature. Here at the bottom, the temperature is around 400 degrees centigrade. Here on going to top, temperatures decreases 400, 300, 200, 100 and room temperatures. Okay, from highest temperatures to lowest temperatures are maintained in the tower by passing steam. Okay, now here the vapor goes up. First coming to heavy oil vapor. Here heavy oil boiling point 320 to 400. That means the heavy oil is in vapor state yet and above the 320 degrees centigrade. So here when this heavy oil vapor reaches this area, in this area the temperature below 320 degrees centigrade. Therefore that heavy oil vapor becomes condensed and converted into liquid and it is separated out first. And next, diesel. For diesel 250 to 320. That means the diesel boiling point 250 to 320. That means the diesel is in vapor state yet and above the 250 degrees centigrade. Here when diesel vapor coming up and when reaches this area, in this area the temperature below 250 degrees centigrade. Therefore, the diesel vapor becomes condensed and converted to liquid and it is separated next. Next, kerosene 180 to 250. So, at and above 180 degrees centigrade, kerosene is in vapor state. Here, up to here, okay, from bottom to up to here, the temperature above 180 degrees centigrade. So that kerosene comes up in the form of vapor state. When it reaches this area, in this area temperature below 180. Therefore, that kerosene vapor becomes condensed and converted into liquid and it is separated out. Next, For next petrol, coming to petrol. For petrol 40 to 120. So at and above 40 degrees centigrade, petrol is in vapor state. So here in the tower up to here, from bottom to up to here, the temperature above 40 degrees centigrade. So that petrol comes up in the form of vapor only. So when vapor reaches this area, here at this area, temperature below 40 degrees centigrade. Therefore that petrol vapor becomes condensed and converted into liquid and separated out. So in this way, different fractions are separated on the basis of their boiling point. But some gases here, they does not condense in the tower. They coming up in the form of gas, as they have very low boiling point, less than 30 degrees centigrade. But in the tower, the temperature from 400 degrees centigrade to 30 degrees centigrade, or to room temperature degree centigrade. So the gases does not condense in the tower, and they are coming out in the form of gas only. Okay. Now, what are the applications of these fractions? Here gases and ether, petrol, naphtha, kerosene, diesel, heavy oil, different fractions are separated from the crude oil by using this fractional distillation process. Now what are the applications of these different fractions? Now first coming to gases, uncondensed gases. So these gases does not condense even at room temperature. They does not condense even at room temperature. So they possess very high combustion properties. Actually, lower hydrocarbon fractions possess higher combustion properties compared to the heavier hydrocarbon fractions. So here that gases does not condense and possess very high combustion properties. So acts as good fuel. So it is used for domestic and industrial purposes under the name LPG, liquefied petroleum gas. Next one, ether. So we know that ether used as solvent in industries and used in dry cleaning process. Next one, petrol. Petrol is used as fuel in vehicles, motor fuel, and also used as solvent and also used in dry cleanings. Next one, naphtha. Naphtha is also used as solvent and in dry cleanings. Next one, kerosene. Here kerosene used as fuel in lamps and used as jet engine fuel. Next one, diesel. Diesel also used as fuel in diesel engine vehicles. Next one, heavy oil. Here the heavy oil means it is heavier hydrocarbon fraction. Heavier hydrocarbon fraction, it possesses very high boiling point and low combustion properties. So this heavy oil is again subjected to fractional distillation process. Here heavy oil again subjected to fractional distillation process to get various useful fractions. So from heavy oil, the useful fractions obtained are lubricating oils. Lubricating oils. Next one, Vaseline. Vaseline. Next one, grease. Next one, wax. Here, when heavy oil subjected to fractional distillation, you get these fractions. Lubricating oils used for to reduce frictions in machines, so used as lubricants. Next one, Vaseline. Vaseline used in medicines and in cosmetics. So in cosmetics used in face creams. So in medicines and cosmetics, Vaseline is used. Next, grease. So grease is also used as lubricant. Next, wax. Wax used to make candles and in boot polish. Okay friends, now it is about fractional distillation of crude oil. Thank you.